So let's continue with the session with Sergio Laso from the University of Extremadura, again about digital twins, state-of-the-art use cases and YouTube.
Okay, hello everyone. My name is Sergio Laso from the University of Extremadura in Spain. In this second part, I try to finish on time. Okay, I promise. In this second part is more focused for specific use cases, new trends, and also I will show you a case study focused on the Madrid M30 that is like a road or highway from Madrid, and to show how to develop a digital twin with the commercial tools that are available nowadays. If you have time, I show you again more use cases, like a little short video, and finally I will finish with commenting two new trends and final conclusion. So the first part of the introduction, I can talk about the digital twin that are being widely explored in different sectors like healthcare, industry 4.0, smart city, a lot of areas. Also, digital twin is a technology with a high impact in the governance, rather for the 1 to 3 years that the goal is to change or integrate into industry with a very high impact. So the main problems or challenges to adopt this digital twin in industry or anywhere areas is this challenge that Carlo talked before some minutes before. The first one is the sensorization and data collection from the real world environment, the fragmentation of the development tools that we have today, high entry barriers and skill requirements for use these kind of tools, lack of reusable models and standardization, and security and data government that maybe is related to the last question in the previous talk. So for the first one, the most exciting infrastructure is not sensorized. Also the real world environment are noisy, dynamic, and expensive to monitor, and install sensor or IT sensor or whatever to get the data and to send to the digital twin involve technical expertise, power supply and communication planning, environmental constraints like weather, location access, and also more investment. In our case, we work with a small company of that drying food, and we work in an AI model to optimize our process of drying, and they spend more than 3 million euros to buy the different machine to sensorize all part of the drying process. So this is very expensive, depends on the content, of course, of the purpose, but usually it's very expensive to sensorize all of things in the real world to get the data to the digital twin. The second part is related to the development tools. There are many platforms. I will show you the most important platform in the next section. But there is unified standard for digital twin modeling. There are ecosystem development like Azure or AWS or Siemens. It's very difficult to communicate or need to interoperate with each other, and this development requires manual data integration and especially running for each tool and extra service, because I will see in the next point that when I develop a digital twin with the tools that I have today, we have to use a lot of services or tools to create a real digital twin. Related with the second point, there are a high entry barrier security requirement, because to develop a digital twin is not a plug and play develop. Requires scaling IoT, cloud services, software, data science, and AI of course. And for example, for the small companies, there is a lack to the who was forced to adopt or develop the system. So there are open solutions like Eclipse Editor that we will see in the next point. But maybe they reduce the cost, but increase the technical complexity because we have to use a different external system to compose the entire digital twin. Of course, there is a lack of reusable models and standardization. Most of the projects are custom made or is an ad hoc solution. This model is not very easy to portable or to interoperate with different platform, and also there is lack of reference architecture model library, but there are different standards like a DDL or W3C that they are growing, but for example, the DTDL will show in the case study that is a bit limited. So nowadays it's not a very customizable. The last one related to the security and data government that Carlos talked in the last question. The digital twin implies the transmission, the different or the important data between the different parts. So exposing this system, for example, out of Europe, introduce risks like a cyber attacks or data breach or regulatory non-compliance. So many organizations are not prepared or there are not a global law how to share this information between the digital twin and the physical twin. So the goal for this session will review the most important tools that are available today for building the digital twin, compare in a general view the features, strength and limitation, and also demonstrate with a practical example that is a digital twin of the Madrid M30 highway. And we will see the different features between them and compare the learning curve of development and some more metrics. And finally, surpassing more use cases and interest on digital twin. About the commercial tool, there are a lot of many commercial tools, well, not many, but increase appears the new tools. But in this case, I put the most six important tools that include commercial cloud platform, open source frameworks, and industrial engineering suites. In this case, I choose Azure Digital Twin, Azure Ecosystem, Siemens, AWS, Oracle, Eclipse Ditto, and PTC ThinkWorks. So I review in a general view the characteristic of the future of each platform, but in the case study I choose only 3 of them to show the difference in the development of the case study. So Azure is from Azure Ecosystem. Azure Digital Twin is from Azure Ecosystem. The digital twin is built by standard digital twin definition language, the DTDL. They are very integrated with the different services like IoT Hub, Function, 3D designs, Azure Machine Learning. They are also commonly used for smart building, transportation, manufacturing context, maybe the summary in IoT context, okay? And the case tracing the real-time telemetry and control from the physical twin. Also, the another case trait characteristic is the 3D studio that can be modeled in 3D the object. Depends of the sample, of course, but in this case, the highway or the road of Madrid. And also, this tool have the capability to predict different things, through the author machine learning. That this is another service. From Siemens Digital Twin is like a engineering suite. It's not like a Azure machine learning or Azure ecosystem. It's more focused for the structural, thermal, fluid, and electrical modeling. It's used in different, well, in this kind of areas. I try to summarize this for explain more the practical part. And the key strength is the integration with CAD or CAE tools for modeling the different objects, and there is trust in industry that require mission critical reliability. Okay. Okay. The next one is AWS. In this case, AWS IoT Twin Maker. But this is the service focused to create a digital twin. It has also the like a 3D visualization enabled to modeling the 3D object, and the usage or the application from this tool is the same like Azure machine learning. So they are different tools that improve the prediction or the connection or the data collection for the digital twin that we will see before in the practical parts. And the Oracle Digital Twin is another suite. Is more for ERP and logistics simple, but it has also AI capabilities and competency dashboard to reporting tool for decision makers, but it's more a suite for this kind of system. This is the only one open source framework, and this framework create or build a digital twin with own JSON based thing. Is the most customizable model to create a digital twin, to create the model, the digital twin, implement APIs and for real-time and asynchronous interaction for the different external services, because one of the most important things that can be integrated with external system, for example, external database, because it's open source, okay? So the key strength is no vendor login, it's lightweight and highly customizable. For deploy, because it's a manual deploy, use Kubernetes and Docker environment, so it's not it's easy to deploy it, but it's a manual deployment instead of Azure or AWS. For the last one is PTC ThinkWorks. This tool is more focused to AR for training or for maintenance application. It's not really a suite, but there are different modules that the cost is a bit higher compared, for example, with AWS or Azure. And the main thing is more focused to AR experience and enriching connectivity with industrial automation protocols like PLC or OPC. So the second point is to show real development of a digital twin. In this case, the highway or the road Madrid M30 is the most important road of Madrid. The idea is to predict the traffic of the different vehicles. This data is collected by the Madrid Open Data, and this information is updated every 5 minutes. I suppose that the real system getting the data more frequently, but for the open data, for the public, is updated by every 5 minutes. The road, there are different sensors like electromagnetic loop under the pavement to get the information about the speed, the number of vehicles, and also from the cameras, but from the cameras, not the images. The cameras obtain the data that is captured by the image. For example, in one frame, there appear 3 cars. So the data obtained is the value of 3 cars, not the image of the road. And the goals is improvement the traffic management, reduction of travel time, or reduction of accident risk. For build this digital twin, we developed this model. It's a simple model. Is use the data from the Madrid Open Data. This model is composed by the road, and is divided by section. That this is like an identification of a section of the road, if there are tunnels or not in this section. And from the district, this is another identification. There are planet work. Planet work is like where are maintenance plans advertised here, or if there are incidents like a car accident is appear here. And the part of the tension when there are a lot of cars in some part of the road, and the sensor means that the sensor of the electromagnetic loop under the road. So for the selector tool, I select this tool for this kind of evaluation criteria, but mainly is for the cost, because 3 of them the cost is very expensive, but one is open source framework, so it's very easy to know what is the selected. But I try to show the limitation of the selected. There are these 3. Azure, AWS, and Eclipse. There are different limitations, okay, but the selection is related to the connection with the IoT devices, or for data collecting, for data collecting from IoT devices is more or less customizable instead of the another. But the main thing is the price, because Siemens, Oracle, and PTC ThinkWorld is very steep. The license is are very expensive. So this is the main reason that we select this tool. Okay, and this is the another reason that not select the other tools. Okay, so the comparison for this case study, we will evaluate the development of this digital twin in these 3 tools. For the next one, I said before that for build a digital twin, we have to know know the different skill on different services. For example, in Azure Digital Twin, this is the service or for the service for the Azure Digital Twin. But for build or for create a real digital twin, we have to know another or a lot of extra services that help or that we need to create a real digital twin. In this case, this is the main component, Azure Digital Twin, that get the data from the real sensor. The real sensor get the data from this service that collect the data from the Madrid Open Data. With these 2 components that we use also there, send a different triggers when the data comes to the Azure, and the Azure function execute different function. For example, for save the data, or for match the data from the Madrid Open Data with the model. I mean, to match the raw data from the Madrid Open Data with the parameter of the models. So the goal is there are 2 goals. The first one is to collect the data and put it in a monitor to get the information to show the information in real time, but also store the information, okay, using this again these services, store the information to predict the next hour about the vehicle traffic. And finally, with this monitor, getting the information from the raw data and the AI model, and send different alerts. In this case, for a Gmail. Okay, it's not. Don't take any action to the physical twin directly. So the idea is to send the different alert to the Gmail to the people that work in the operational part of the roads of Madrid. So the idea is to send different alerts about the traffic vehicles in this case by Gmail. Okay. So in this case I show the different screenshots, but not seen very well. But okay. The Azure IoT Hub is related to the IoT device management to get the data from the Madrid Open platform. The Azure function is to match the raw data with the model of the digital twin. The next step is modeling the Azure digital twin. In this case, that I said before, Azure use the DTDL specification, but it's compared to like a graph, okay, with different nodes, so it's more easier to modify. And also it's possible to model in 3D, in this case like a part of the road, to color mark with different colors, depend in this case with the intensity of the vehicle traffic. From this, the information is sent to the monitor, okay, from the not real time, but from the Madrid Open data, and also alert by Gmail. But also this information is come to the machine learning part, okay, to evaluate the data, and predict with a model, and also send another alert with for the few minutes after. For the next tools, the idea is more or less the same: is to get the data, show the data in real time, and also predict the difference, predict the vehicle traffic. In this case, with Eclipse Editor, we have to know also a lot of services. In this case, Eclipse Editor is compatible to integrate like external tools, like for example a database, a Postgres database, or Grafana. But in this case, Eclipse Editor is compatible with Mosquito, that this is an MQTT broker to receive or send the information, and Eclipse Ono is like the Azure IoT Hub that get the information from the real data and send to the Eclipse Editor. We put this component because I said before that Eclipse Editor use Kubernetes and Docker to deploy it, and also use MongoDB to save the different log generated by Eclipse Editor. But in this case, the data from the road is saved in a Postgres database. In this case, it's possible to connect to like a 3D visualizer like Unity, but in this case we couldn't do this part. So the information is only shown in Grafana, and from Grafana send the different trigger of the different alerts. In this case, to Telegram. And also I forgot the part of the AI. We use deep learning for this. It's another open source framework compatible with Eclipse Editor. It's like a AI model based on Java and Scala, I think. But it is in our case in Java, okay. And this model predicts the traffic vehicles of the road. So in this case, I show you like a different screenshot from Eclipse Editor. In this case, Eclipse Ono is used by a command line. Okay, it's less usable than, for example, Azure. Eclipse Mosquito is only the broker to communicate the information between the different components, for example, to Eclipse Dito or for database. Okay. The Eclipse Dito, the main interface is only focused to model the digital twin, the different parts of the digital twin. One of the strengths of this modeling is that it's very customizable. We can define everywhere object because it's very customizable instead of DTDL language, for example. And this is a strat of deep learning for G. This is like a method to predict the vehicle traffic in Java. Okay. The last part is Grafana and Telegram, and well, more or less say that this is an alert that the number of vehicles is very high in some part in the district, two from the road. In Grafana we can see the real-time data, and also they predict values from the AI model. So the last tool is AWS IoT Twin Maker. In this case, we have to also use a lot of services. For example, AWS IT Core for get or for connect the data from the data sources, the Lambda function to execute different function to send the information of the sensor to IoT site-wise. The IoT site-wise is like a control, like a data control for the IoT devices, or for the data from the road. And in this case, we use for save the information and for evaluate or for predict values the typical safe storage like Amazon S3, and for predict or for use AI model we use Amazon Lookout for equipment, or also SageMaker. In this case, we use also Amazon Grafana. It's not like an original Grafana, it's like a modified version that includes like a 3D model in real time for put the data from the real sensor, and also for the digital twin that obtain the predict value for the from the Amazon Lookout for equipment. And in this case, like in the Azure, the different alert generated or sending by or detected by Grafana is sending to Gmail. So in this case, I pass for the most important screenshot. This is the different sensor or the data connected to the IoT site-wise. The IoT Twin Maker, we also include like a 3D modeling part to create our 3D model. We can also import like a different 3D model extension. I don't remember the extension, but the tool support like a 3 or 4 different extension of the model, so we can download a model created by another user and use for this purpose, if it is possible. Related to the Amazon Grafana, in this tool we can see the different data, the predict value, and also like the 3D models, but with the real data, and also marked with different colors depending of the intents of in this case the data traffic. Okay. And finally, finally the part of the machine learning, we use Amazon Lookup to detect or to predict different data traffic vehicles, the intents of the traffic vehicles, and when there are the alerts about the traffic vehicles, the alerts is sent to Gmail, to people that control the part of the operation of the robots in Madrid. So to summary the comparative of this tool, we can see like a summary of for this case study. The most important thing I think to say in this slide is the price. This is not a real price because we use like a free tiers on different services, so it's not maybe a real price for the next month. About the development time, we can see the different development time. The most harder tools was Azure, the second was Eclipse, and the first, or the more usable was, or more easier to develop, was Amazon. In this case, for Eclipse, we need to install different software, in this case Docker and Kubernetes, to deploy it, but also we have to install the another components like a Postgre database, Eclipse ONO, and another services. In the case of the Azure and AWS, all of these extra services is included in the ecosystem. For the price, in this case, Eclipse is zero, but really we need to deploy the Eclipse and another service in a server on our computer, so we have to take account the energy consumption at least, or another extra prices. For another parameter to comparative, the open source, we know that the Eclipse is open source. For the modeling thing, I forgot that the AWS IoT Maker define a model like a own model is more limited than Azure. So the Eclipse is the best for modeling a digital twin. Related to the scalability is more or less the same. For the Eclipse editor, we need a very high infrastructure to scale, but it is possible to scale. And related to the integration with other systems, Azure and AWS is all integrated with their services, but Eclipse, we say that it's possible to connect, for example, to Postgre, SQL, to Grafana. It's like a other system or other software. For summary, we put the different tools that we need to deploy a digital twin. That when we talk about to create a digital twin, we only think in AWS TeamMaker, like a Eclipse editor or Azure digital twin, but really we need a lot of services or tools to deploy a real digital twin. And finally, on this slide is to show the learning curve. But we saw before that the most harder tool was Azure digital twin. The second one was Eclipse, and the third, or the first one to more usable to develop a digital twin was AWS. This analysis was did by a student. It's not a very high analysis. It's only one it's only for one person. So it's not really depends of the person. Maybe it's more hard to use Eclipse than AWS, depends of the. But in this case, AWS was the best for develop a digital twin. So to finish this presentation, I have more use case. We don't have time. We have only 5 minutes to finish. So I skip this part. This is like videos for NVIDIA that show a different factories that use digital twin, use a technology created by NVIDIA. In this case, it's like a factory by BMW. So I skip this part and goes to the last part. Is related to the new trends. It's not a NVIDIA promo, but the video is very illustrative to show the potential of the digital twin. Related to the new trend, I saw very briefly the human digital twin. Why we need a human digital twin? For the next generation of industry, like Industry 5.0, smart city or smart vehicle, the collaboration, the human collaboration with the system is the most important thing to optimize much better the different process. But what are the challenges for these paradigms or for this idea? The architecture, the integration, the interoperability, the privacy and security, of course. And for research laboratory, we propose an architecture, okay, that we can find in the internet computing and was published this year, and like a distributed human digital twin, because we don't need like a monolithic digital twin or human digital twin in one place. We can interoperate or communicate with the different digital twins, like for example, like a personal digital twin that is composed like a health data from the smartwatches, the location of the movement pattern from our smartphone, and for another, for our vehicle, we can have another human digital twin related to the driver patterns, emotional status for driving, and connected with a digital twin for the car, and also with the workplace, that we have different measures like a physical data, cognitive data that connect with the machine, or in this case like a manufacturer airspace, and optimize the different things. And also we can communicate, for example, from our personal digital twin, the movement pattern with the city, to improve the bus lines or another thing, or to improve the traffic vehicles with the digital twin of the car. And the idea is to distribute this digital twin in different layers, like a computing continuum layer. So depends of the content. For example, the personal digital twin will be deployed near to us, or the digital twin of the car, and the smart city or the work digital twin we deploy maybe in a upper layer, like in a city or in a factory. So for this idea, we propose also like an architecture with the different part in the architecture. We can see like different tools or different demo that provide for the different boxes in the architecture, because we prepare like a little demo and deploy with the different part of the architecture. But in this case, we don't have time to explain in depth. But if you have questions in the coffee, I open to answer all questions about this idea. And also the last idea is a digital twin as a service. Why is be possible to get a digital twin as a service? Because companies, or many companies, don't need to build their own twins. Maybe they can to subscribe to like a cloud services to get our digital twin, or helpful for startups or for the small companies. But also the challenge will be the integration, the interoperability between the different digital twin, the privacy and security, and also the most important thing, the vendor location. So I finished on time. Okay, this is a very briefly conclusion. The digital twins are powerful, able to predictive analytics, optimization, or real-time decision making, but we have to, or despite the growing body of the use cases, there are a lot of use cases, is still challenges due to lack of sensorization, fragmented tools, or high technical and financial barrier that is not possible to deploy all the digital thing or all use cases. So yes, I have a little time, Thank you so much for your attention. This is my email for ask my question or my LinkedIn. Thank you so much. I hope to answer all of your question. Thank you.
Thank you, Sergio, for also this nice presentation about digital twins tools. Are there any open questions?
I'll see how it works. Look like you had a very excellent qualitative comparison of different digital twin platforms. But what about quantitative? Because I think for a city like Madrid, the amount of data you generate will be quite enormous, and probably that will be the most decisive point for you to decide between the platforms.
Yeah, yes, it's a very good question. But in this case, was like a very small case study. So to measure the quality of the goal of this case study is to try to show how is the hard to develop or to deploy a digital twin. We predict different values, but we didn't measure the quality about the values. The purpose of this comparison was how is to deploy a digital twin with this tool. That is very good.
Are there any other questions? Okay, then I have one. We saw during your talk and as well as from the talk from Carlos that the realization of a digital twin requires many knowledge in various topics. Are there any approaches to lower maybe the barrier to realize digital twins? Like low-code approaches, are there some direction for this?
I don't know about. Yeah, I don't know. I don't know this. No.
Okay. No. Okay. Okay. I mean,
Yeah,
it was far away from the topic,
yeah.
but this was. Any other questions? Okay, then I close this session. Thanks again for your presentation, and let's go to the poster session.
Coffee break is at the poster session to make you go to the poster session. Achso, ja. Wäre schon gut, dass es nicht so kurz war. Die anderen Vorwahlen, das ist ein längeres Meeting.
And it seems to be like a machine learning a little bit like behind. So if you've been taking on
Prego, prego ragazzi, prego.
this problem and having somebody that makes it work is ideal
Good to see you again.
Fällt alles aus.
Absolut, genau.
Ja, mich würde
Ich hatte wieder gedacht,
alles gut, jetzt mein Trotzdem dabei.
Sì,
Or what? Really? I think our university is like
I'm impressed with some hours and what I remember of it. And apparently they are going for the record. Same things
I think that also would fit perfectly. We have to put the reference of the authors inside the languages.